we know how to find the Laplace transform from the previous lecture. So in this, let's talk about how to find the inverse Laplace transform. So the inverse Laplace transform, inverse Laplace transform. So what is the inverse Laplace transform? So let's give the definition. So we say that if Fs is the Laplace transform of small f t function for some function for some function f, then we say, or we define, then we define the inverse Laplace transform. Then we define the inverse Laplace transform, inverse Laplace transform, the inverse Laplace transform to be, so we just write backward. So we can say the inverse Laplace transform of Fs is simply Ft. So it is like exact like you integrate. So if you know the derivative, you can go backward. It's the same thing. So so that means if you know the Laplace transform, we can simply write the inverse Laplace transform reversing the process. So let's look at an example and then it will be very clear. So how about this one? So we start with this. So let's say so let some Laplace transform is 1 over s plus 1. Let's say we know this. We see some Laplace transform. So the question is find the inverse Laplace transform. Find the inverse Laplace transform. Inverse Laplace transform. Find the inverse Laplace transform. So what's the idea? So the idea is we can simply say that the inverse Laplace transform of 1 over s plus 1 is simply e to the, here you can see we can see plus 1. Remember we had a formula there, we have a is opposite sign, so a is so when you have a, so in this case like a is 1, so you can see, so then we had a formula what that says is minus a t. So that's exactly what we're going to do here. So that means it's simply e to the minus a is 1, so it's 1t, so that means minus t. We can say since the Laplace transform of e to the minus t is 1 over s plus 1, because that's what the difference is. If you know the Laplace transform, just go backward. So since we know that the Laplace transform e to the minus t is 1 over s plus 1, the inverse has to be, inverse of 1 over s plus 1 has to be e to the minus t. That's what the differential says. So it's very simple. So that's the kind of argument we use. So we try to kind of see if you see an expression of s, we can see what is the Laplace transform of that, what function we start with, and then we can write that function as the answer. So it's a very simple idea. So what we normally, what for that, what we need is we need to kind of remember like few common ones. So let's talk about that. So let's talk about some common ones. So I say common Laplace transform, or we just is like common Laplace transforms. So let's start with something. So let's start with this one. So we know that So we can say 1. So the Laplace transform of 1 is 1 over s, and the Laplace transform of t is 1 over s squared. And then we can have the Laplace transform of t to the n for positive integer n. So it is n factorial over s n plus 1. So this one gonna work for n going from 0, 1, like that. So if n is 0, so you're gonna get this one. So that's the n equals 0 case. The reason is we know that the factorial 0 is 1, so we can use that fact. So we use the fact that factorial 0 is 1. Good. And then the e function. When we have e function, e to the minus at, which is simply 1 over s plus a. So these are like very useful ones. And then sine cosine. So we have so the Laplace transform of sine omega t, which is omega over s squared plus omega squared plus omega squared. And then we have Laplace transform of cosine omega t, so which is s over s squared plus omega squared. And then we have the hyperbolic function. So we have sin omega t. Omega is just a constant, which is the same thing but with the opposite sign. So we can put a minus sign here. So that's the only difference. The minus sign, this one has a plus sign. And the Laplace transform of the cos function is very similar to the sine one, but with the minus sign. So these things gonna help you because these are the common ones and we can use them everywhere. So let's remember them. Good. So now one of the other thing is we know that the Laplace. So we can write a note. The other one is so the simple note. So you can say since the Laplace transform is linear, Laplace transform is linear, the inverse Laplace transform is also linear. The inverse Laplace transform is also linear. So this is like useful. For example, we have these two properties. One is the inverse of, so let's say a constant time fs. If you have something like that, you can just pull the constant out and take the inverse of fs. And the second one is if we have a sum, if we have two functions fs and gs, what we can do is we can split them. So it is, we can write this one as L inverse fs plus L inverse gs. So this is very easy to prove just using the definition, but we can use them a lot. So what it says that, so those are two properties. If you have a constant, you can pull the constant out, and if you have a sum, you can split them. So we can use those two when you do problems, okay? Because the Laplace transform and the inverse transform both are linear. Okay, so let's try to use these and try to solve some problems. So as the first example, let's try to do this one. So we can start with so let's say so find the inverse Laplace transform. Inverse Laplace transform. So the first one. So let's do L inverse. How about 3 over s to the 5? So if you get something like that, what we're gonna do? We're gonna match with the formula. So in the formula, we know that we have s to the n plus 1 formula. So that means if it is s to the n plus 1, so what's the formula? So let's write it here. So the formula is we know that Laplace transform of t to the n is n factorial over Sn plus 1. So this is very similar to this one. So in this case, n is simply 4. So if n is 4, we need 4 factorial, but we don't have 4 factorial here. So what we're going to do, we're going to write the top and bottom. So we can write this one as factorial 4 and then L inverse. And also we can pull 3 out. So I'm going to write 3 also out. So we can put 3 here, and then we can write this one as factorial 4 and s to the 4 plus 1. Then we know that this part, we know the answer for this part, because this is simply the Laplace transform of t to the 4. So we know this one. So this is simply Laplace transform of t to the 4. So what we have inside is, so this is going to give you t to the 4. So that means your answer going to be very simple. So using this one, then we can say this has to be 3 over 4 factorial t to the 4. Now what we can do is we can simplify this a little bit. We have 4 factorial. 4 factorial is 4 times 3 times 2 times 1, and then when we have 3 on top, it's going to get cancelled. So that means you're going to get 8. So that means simply the answer is 1 over 8 t to the 4. So let's do another one. So how about this one? So let's say inverse transform of 1 over s squared plus 5 maybe. So if you have something like that, what you can do is you can simply match with the formula. So you can see that 1 over s squared plus 5, that means this is going to match with 1 over this is going to match with omega over omega squared plus I'm sorry, it's going to match with omega over s squared plus omega squared. That's the sine version. So what we don't have here is the term that we need up there. Actually, let's do an easy one first. I'm going to like kind of change this problem a little bit. Let's do, I'm going to put like 4 here, because it's the first example. Let's put 4 here. So, and then you can see that, so this is 4 means 2 is squared. So that 2 is missing. So what we can do, we can write upside, inside, outside 2. So we can multiply and divide. So we can write 1/2, then L inverse. We can write 2 over s squared plus 2 squared. We can write it like that. 2 over s squared plus 2 squared. And then you can see that once you write it like that, this is easy because we know this one. So this one is simply going to be, this is the sine version. So this is sine 2t. It's simply going to be sine 2t. So that means the final answer going to be, you can write this one as 1/2. That's already there. And the sine 2t. So that's how the simplification work. So if you don't have a term, what we can do, we can multiply and divide by that term. So like here and there. And then the inside one you can write as sine 2t, and then it's going to be 1/2 sine 2t. Okay, so how about this one? Like if you have, let's say, the third one, L inverse, let's say 3s plus 3s plus 2 over, let's say, s squared plus 5, something like that. So if you get something like that, what you can do is, you know that this is not really a direct inverse. So what we normally do is, using the linearity, we can split this first. So we can write this one as, we can take 3 out. So if you take 3 out, you can write this one as 3 L inverse S over S squared plus, you can see this one as square root 5 squared. You can write it like that. Plus, and here we can again pull 2 out, and then it's going to be L inverse 1 over S squared plus 5, and then we're going to see whether this going to match with anything. So you can see the first one going to match with the cosine. So that's the cosine. So that's the first one is okay. So if you look at the first one, you can see that this is simply the cosine. So this is cosine omega is square root 5, or is square root 5 t. So that's good. But what about the second one? Second one, we had used the same trick that we used before. We're going to find what is the omega. Omega means the square root of the constant term. So we can look at this term and take the square root, but that part is missing. So what we can do is, we can multiply and divide by that. So we can do that. So we can write square root 5 here and divide by square root 5. So we can do that. Okay, and after that, then we can see this is simply this part. Now the sine square root 5 t. So that means the final answer going to be, now it is 3 cosine square root 5 t plus, here you can write this one as 2 over square root 5. It is okay to leave it like that. And then this can be sine square root 5 t. You don't have to do the rationalization, so that's okay. Yeah, so that's how we do it. So this is like a nice simple trick. So we split it first, and then we're gonna bring it to the right form. Sometimes we're gonna see, like in the cosine one, what we need is, you need to have the s up there, and then in the bottom it has to be a squared plus square root 5. In this case, like squared plus omega squared. In the sine version, you want to make sure that you have the square root of the bottom term, and if you don't have it, you can multiply and divide by that. Okay, so those are the kind of basic tricks that we can do for these kind of problems. Now let's try to see, yeah, in the third one, actually in the third one we use the linearity, because if you have two, we can split it into two. Now let's try to see, like there's another major technique, what we call the I mean, we know that in Calc 2 we use the partial fraction method. So there's a major application of that for Laplace transform. So let's talk about that. So we can talk about the partial fraction method for certain problems, because those are not going to be like really easy like that. So what we need to do is, we need to sometimes look at the partial fraction and get the answer. So let's do a problem like that. So the partial fraction method. So I'm going to do like a various type of problems. So it might make the video a little long, but I want to make sure that we kind of cover like all different type of things, so it can be useful for you. Um, so let's start with like a problem like this as the first one. So I'm going to go with this. So let's say find the inverse of. So it's like actually D here, but let's start with a new problem. So let's say find the inverse Laplace transform of inverse Laplace transform of let's say 4 over s squared plus 4. So you get something like that. So you can see a product. Find the inverse Laplace transform this. So what we can, if you see a product like that, what we normally do is, if you cannot see it right there, uh, what we normally do is we can directly go to the partial fraction method. So let's try the partial fraction for this. So use a partial fraction. So we can write the form first. So the form of this one is, so we can write 4 over s squared plus 4, which is identical to, don't write the equal sign. Equal sign is not exactly correct for these kind of problems. It should be identical. So what we can do, we can write each factor. So it is a over s plus the bottom is s squared plus 4. The degree of the numerator is 1 degree less than the denominator. So that means this has to be b s, this has to be linear. So bs plus c. That's what we get. Now what we normally do is we're going to multiply by the denominator of this side. We're going to multiply by that, the whole expression. Once you do that, you're going to get 4 identical to a. You can see s get cancelled. You get s squared plus 1. You only get the other ones. Here s squared plus 1 get cancelled. So you're going to get bs plus c times s. That's what you get. And then after you get to that, we can use the hybrid method. What's the hybrid method? We can start substituting values if it's gonna work, and then we can substitute. We can equate coefficients, and then we also substitute values. That's a hybrid method because that's much faster when we solve many problems. So you can see that here. So we can substitute s equals 0 because this says that you have to substitute s equals 0, because then you can make that factor 0. So let's do that. So we're going to substitute s equals 0. Once substitute x equals 0, you're going to get 4 equal. Now it is equal. 8 times, if you substitute 0, so this is going to be simply 4 plus 0. You see that? The whole term is 0. So this says that a equal 1. So you're going to get there, right there. Get the a. And then we're going to start equating coefficients. We're going to always start with the largest coefficient. So we can do coefficient of the largest term is s squared. So we can go with that. There are no s terms, that means coefficient is 0. Here you can see this one has a s squared term, so the coefficient is going to be a, just a. And then if you look at the next term, this is also going to create a s squared term. When you multiply these two, that means the coefficient is going to be simply b. So this says that because we already know that a is 1, so this says that b has to be negative 1. So we find b also. And then we're going to go with the next coefficient. So we always start with the highest one and then go down. That's what we do because it's much faster. You're going to get the answer really quickly. So and then the coefficient of s. So there are no s term here, and there are no s term in the first one. But in the second one, you can see that the coefficient is simply, the coefficient of s is simply when you have to distribute. Once you distribute, the only way you can get a s term is multiplying these two. So that means the coefficient is simply c. So this says that c has to be 0. Okay, so we find ABC all three. Now we know the partial fraction for this. So that means we can write the final answer. It is 4 divided by s, s squared plus 4, which is equal to, now you can write equal to a is 1, so it is 1 over s, and then b is negative 1, so the minus s over s squared plus 4. That's exactly what we want. Good. So that means we can write the answer right now because we know this is 1 over s minus 1, s over s squared plus 4. So that means the answer is, so we can write now L inverse. So we have 4 over s squared plus 4. You can replace what is inside by the Laplace, the partial fractions. It was 1 over s minus s over s squared plus 4. You can split this into 2, so this is L inverse 1 over S, L inverse 1 over S minus L inverse S over S squared plus 4, and we know both of them. The first one going to give you this 1 over S, that means 1, minus this is here you can see omega equal 4, so you can see that this is 4, so that means omega equal 2. So omega equal 2, so that means your answer is cosine 2t. So that's the answer. So that's the inverse Laplace transform of that. So you can see that that's not really difficult. So we simply use the partial fraction method to solve the problem. But I'm going to show you like another tricks, like shortcut method sometimes work, but not always. So let's see that. So I'm going to say the method 2. Method 2. We notice that 4 over S squared plus 4. So what we're trying to do, we're going to see whether we can create one of those terms up there. So we already see the 4. So what we're going to do is I'm going to write this one as S squared plus 4 minus S squared. You can do that. You can add and subtract. Okay, so we can do that. So what we did was we add squared, we subtract x squared. Now what we can do is we're going to split this into 2. So I'm going to collect the first two terms, and I'm going to write this one as s squared plus 4 over s times s squared plus 4 minus, that's a minus sign, and then s squared over s squared plus 4. Now you can see that there are a nice simplification here. So you can see that this term cancels with that term. So you simply get 1 over s here minus, and you can see that one of the s you can cancel s with one of them, so you only get 1. So that means you gonna get s over s squared plus 4. You can see this is exactly what we want to get. So that's the exact same partial the answer that you get from partial fraction. So this is the same. It's the same. So that's like a kind of quick way to get the answer. But now the problem is, if you see some other number here, you're gonna see like 4. Well, but what if like you're gonna see like 3 or something? So if you see 3, so what we can do? So this is like if you have 4 here, but what if you have 3 here? So if you have 3, can you think of a way to do this? Because we know that these are linear, so you can always multiply and divide by numbers. So what we can do is we can write this one first as, I'm going to pull the 3 out, 3 over 4, so we can out, and then we can write this one as 4, not 4, we can put 4 over s squared plus 4, and we can do the same thing that we did before. So it is just 3/4. Inside we do the same trick. We're gonna write this one as s squared plus 4 minus s squared over s squared plus 4, and then we're gonna split. So once we split, we're gonna get the same thing as before, so it's gonna be 3/4, and then we're gonna get here from the first one you're gonna get 1 over s, from the second one you're gonna get s over s squared plus 4. So only change that you're gonna see is you're gonna see a 3/4 factor, but that's okay. So we have 3/4 1 over s minus 3/4 s over s squared plus 4. But 3/4 is just a number, so it doesn't do any harm. So what we can do, we can just multiply by that when you write the answer. Good. So this is like some of the tricks that you can use for to solving problems like that. So remember the idea, like just basic algebra, but it can save a lot of time when you solve certain problems. Good. So this is the major technique, what we call the partial fraction technique. So let's see, let's try to like some slightly different problems. For example, this one. Uh, let's say you try to find the inverse Laplace transform of this. So the next example, find the inverse Laplace transform of s plus 1 over s minus 1 s plus 2. Same idea. So you can see a rational function. These are what we normally call the rational function. So if you see a rational function, we can always do that. Um, so let's try the partial fraction form for that. So we're gonna have s plus 1 over s minus 1 s plus 2 equal each factor. There's no order, just write first one and the second one. We normalize this as an identity. Good. Now we're gonna multiply by the denominator. So we're gonna multiply by that both sides. So you're gonna get s plus 1 identical to a, the other one. So s plus 2 here, b s minus 1 here. Always get the other one because whatever in the denominator get cancelled. Now we can use a substitution technique because that's much faster. So we're gonna find the correct substitution. So if you want to find a, we want to think of how to make this 0. So that's the idea. If you want to find a, you want to try to make the other term 0. So that means you want to find s equal 1. So we're going to say s equal 1. So we substitute s equal 1. So substitute s equal 1. So then you're going to get 2 equal a times 3 plus 0. So this is going to give you a right there. So a equal 2/3. Do the same thing. We're going to substitute s equal, to make the other term s equal -2 now. If you are -2, this the first term gets 0, so that means this is going to be -1 equal 0 plus b times, if you substitute -2, it becomes -3. Yeah, so you're going to get -3 because you have s equal -2 with that negative sign -3. So that means this can give you b equal 1/3. You can see b is going to be simply 1/3. So this 1/3. So we have the answers now. So that means you know the expression now. So that means your answer is simply going to be this simply equals to a is 2/3. So 2/3 over s minus 1 plus b is 1/3. 1/3 over s plus 2. Good. So now we can write the answer, because after we get the partial fraction, we can write just the split. So L inverse s plus 1 over s minus 1 s plus 2 equal, we can split them into 2. So what we normally do is we're gonna leave the constant out. So it is 2/3. So it is 2/3 L inverse 1 over s minus 1 plus 1/3, whatever the constant, take it out with the sign. So, and this can be 1 over s plus 2. And we know this, we have a formula. So for example, remember the formula when we have the Laplace transform of the eat function, e minus at is simply 1 over s plus a. You can see that's exactly the form we have in both. in the first one a is -1, in the second one a is 2. So that means the answer is simply 2/3. This is going to be e, because here a equal -1. So this one a equal -1. Here a equal 2. So that means if you plug in that to the formula, so you're going to get so equal. Yeah, actually there's a mistake. This is a equal -1 in this one. So this is a equal -1. Yeah, equal -1. So and then with the negative sign, so it's a -1 t plus. You don't want to solve this algebra, but if you want to, you can do that just to make sure that. So see, because there's a minus sign already there, so it is -2t. So that means finally you're going to get 2/3 e to the 2t plus 1/3 e to the -2t. So that's the answer. This step is optional, but you can try that. That's okay. So that's how you do the problem. But you can see that's not that difficult, but there are certain steps that you want to do. But if you kind of have trouble finding partial fractions, I would ask you to look at the partial fraction video, because that clearly explain all different types that you need to learn, especially in Calc 2. Okay, so that's about that. How about a? So I'm gonna like to do a two more. Yeah, actually one more type. One more. Yeah, two more problems. So let's do another one with three factors. Okay, how about three factors? Uh, so I mean, technique is the same. So it's not a big difference. So it is, let's say, L inverse of this problem. S squared plus 6s plus 9 over let's say s minus 1, some numbers, just put some numbers you like, and then s minus 2, and let's say don't put s plus 3 because then it's going to be a factor of the top and there are some issues. So let's say s plus 4, not 3 but 4. Good. Okay, so the same idea, we can write the partial fraction first. So we can write s squared plus 6s plus 9 over s minus 1, s minus 2, s plus 4. And when you have linear factors, you can also use a shortcut, what we call the covering method. But these are like easy. So it doesn't take more than a minute to find everything. So it is a over s minus 1, b over s minus 2, c over s plus 4. And then we know what to do. We can write multiply by the denominator. So you get s squared plus 6s plus 9 identical to 8 times the other two. Yeah, we have a little bit of writing here. So it is s minus 2 s plus 4, and then b s minus 1 s plus 4, and then with c s minus 1 s minus 2. I mean, that's it. That's the only step we want to write, because then you're going to get ABC right there. So you can see, for example, if you want to find A, see what is common to others. You can see is this common to other two. So that means if you plug in s equal 1, the other two terms get cancelled, you get A. So that's the secret. So we're going to substitute. We're going to substitute s equal 1. Right after you do that, you're going to get here 1 squared 169 equal A times, just plug in s equal 1, so you can get -1 and then 5, and everything else is 0 because all those terms gonna go, and then you're gonna get A there. So what is A? You can see that A is here you're gonna get 16, so it is A equal -16 divided by 5. So we get A. So same thing. So let's go with the other one. Let's say substitute. So if you want to find B, what are you going to substitute? Look at the other two terms, see what is common. You can see s minus 2 is common. So we're going to substitute s equal 2. So substitute s equal to, when you do that, you're going to get 4. And then when you do 2 is 12, and then 9. You don't want to solve this step, you can just write the number, but I'm writing it. And then you can see this is 0 plus b. So you plug in 2. If you plug in 2, this can be 1, and then 6 plus 0. So this is going to be b. So what is b? So you're going to get how much you get there? You can see 16. So 25 over 6. So you're going to get 25 divided by 6. Perfect. And then if you want to find c, again look for the other two terms. So you can see s plus 4 is the terms. That means you multiply s equal negative 4. Opposite one always. So we're going to substitute s equal negative 4. Once you do that, so negative 4. So it is 16, and negative 4 means negative 24, plus 9, 0, 0, and then c times, you plug in negative 4. So negative 4 means negative 5, negative 4 means negative 6. And then let's simplify, and once you simplify, what do you get? You're gonna get you can see 16 plus 9 is 25 is 1, so it is 1 over 30. Okay, those are the numbers that you get. Everything looks good. We can write the answer now. So you can see L inverse. We can write this quickly, and then s minus 1, s minus 2, s plus 4 equal, we're going to split everyone. So a is negative, so I'm going to write the constant out. I'm going to write the constant out. So the constant is 16 over 5 L inverse 1 over s minus 1. b is 25 over 6. 25 over 6 L inverse 1 over s minus 2 plus 130 L inverse 1 over s plus 4. So we can do as before in the 2 case. Now they have 3, just the same thing. In this case, you can see that a is negative 1, a is negative 2, and then here a equal 4. So if you plug into the formula, you're going to get the answer as negative 16 divided by 5 e to the positive t, because there's a negative sign in the formula, and then plus 25 over 6 e to the 2t, and then plus 130 e to the negative 4t. So that's the final answer for that. So you can see that that's not that long. So you need to find the right substitutions to find the ABC directly. So you can see it's not that long. You can just clearly find them easily. Okay. So if you are interested, you can use the cover-up method. The cover-up method can give you the numbers quickly, and there's a separate video for that. You can watch that to find the how to do the shortcut. But that's only for linear factors. If you see linear factors, non-repeated linear factors, you can use the cover-up method. So what you do is just to get the fraction, just cover up a term. So for example, you can cover, like for example, let's say you want to find a. So what you can do, you're going to simply cover up this term, because that's where you're going to get the a term. And then what you're going to do, you're going to substitute for the rest of the fraction s equal 1, because s equal 1 makes that term 0. So we know that s equal 1 made that term 0. Just plug in s equal 1 to the rest of the fraction. That's the a. You can see that once you plug in that, you're going to get negative 16 over 5. Okay. For example, I show you that. Okay, let's do that. That's the cover up for linear factors. Yeah, why not? So the cover up method. This works for only when linear factors. Okay, so cover up method. uh, for linear factors. Cover-up method for linear factors. So let's do the same problem and see how fast you can get it. So what we have is we have s squared plus 6s plus 9 over we have s minus 1, s minus 2, s plus 4. So let's see how we can find the answer. So the goal is we have a over s minus 1 plus b over s minus 2 plus c over s plus 4. So the question is how to find a, the coefficient of s minus 4. So what we do is so that's the term, so we figure out that's the one we need. So we carve out the corresponding one. We're gonna ignore this term, and then we know that we need to make that term 0, we need we need to plug in s equal 1. So what we can do, we're gonna plug in s equal 1 for the rest of the term. So pick the rest of the term. So just the other term, the rest of the term. So that means we only pick this part. So we just pick that part and substitute s equal 1. So that means so a is, so we pick the other part, s minus 2 times s plus 4 and substitute s equal 1, because s equal 1 makes that term 0. And once you substitute, you can see you directly get the answer, because if you plug in s equal 1 is a 1 plus 6 plus 9 over, in the bottom if you plug in 1, this is negative 1 and this is 5. You can see this is exactly negative, it's exactly negative 16 over 5. Yeah, so that's what we call the cover-up method, and you can just use that to find everything else as well. So for example, what is b? So b is simply s squared plus 6s plus 9 over, so you can see if you need b, you can cover up the other term. So it is s minus 1, s plus 4. So you're going to plug in s equal 2. That's the same number that is used for substitution. So if you plug in 2, you can see this is 4 plus 20. So it's you plug in 2 is 12 plus 9 over, you plug in 2, so this is 1 and 6. So you're going to get 25 over 6. And then if you want to find c, do the same thing. S squared plus 6s plus 9 over, we have, what are the other terms? So write the other terms. So s minus 1, s minus 2, you substitute s equal negative 4. S equal negative 4. Okay, so this says that s equal 1. For that we use s equal 2. For that we use s equal negative 4. So if you do that, then you're going to see, so negative 4 squared is 16, negative 24 plus 9 over, you substitute negative 4, so you're going to get negative 5 times negative 6. And in the top, you can see this is 25, so it's a 1 over 30. Yeah, so that's the what we call the cover-up method. It's very simple. Just substitute the value, you get the answer. You can even do that there. So you know if you can do algebra fast, you don't want to write those things, all of them. Okay, but that's a cover-up method. It works for linear factors. In the bottom, it has to be linear factors, linear different factors. Then this is gonna work. Okay, can be any number of terms, but it's gonna work. Okay, so let's do one more different problem. So we're gonna go back to Laplace transform. So now let's do a different example which does not use the traditional partial fraction method. So let's do this problem. So let's say L inverse of s cube minus 12 over s squared times s squared minus 4, something like that. So you can see that this is a rational function. So what we normally do is we're going to go for the partial fraction technique. But we had like a different type of partial fraction for this one. So what we have is s3 minus 12 over s squared, then s squared minus 4, which is identical to, we know that we have the s squared term here. So that says that we have to write a over s plus b over s squared. So this is the traditional partial fraction argument. We're gonna follow the pattern of the smallest term. So we have to write everything, not just s squared, you have to write s also. Okay, perfect. Now what we have is, what we normally do is we're gonna factor this one. So there are two factors, s minus 2 and s plus 2. In the calculus 2 technique, what we normally do is we're gonna write two factors, for one for s plus 2, one for s minus 2. We do not do that when you do the Laplace transform. The reason is we have a formula in the table that has a squared minus kind of term in the denominator. So because of that, we're gonna stop right there. So that means our form we can write as cs plus d over s squared minus 4. So you can see that this is different from the traditional calc 2 argument. So this is different, because in the Laplace transform there's a formula for s squared minus 4 in the bottom. So because of that, we don't do that. We can stop right here. Okay, good. Now after that, what we know what to do. We're going to multiply by the common denominator and then write the form. So the goal is to find ABCD. So we write s3 minus 12 equal, we write the missing term. We're going to simply compare the denominator with the original denominator and write only the missing term. So here the missing terms are s is missing, and then s squared minus 4 is missing. And if you look at the next term, you can see that only s squared minus 4 is missing. And here you can see only the s squared is missing. So it is cs plus d, and you can see only s squared is missing. So what we normally do is we can use the hybrid argument, because the hybrid method is the fastest. Um, so let's do that. So when you do the hybrid method, we normally start with the substitution first, because that's going to give you some values quickly. For example, if you plug in, you can, which one is easy to find? You can see that b can be find much faster, because if you just plug in s equals 0, you get b. So we're going to go with that. So we're going to say s equals 0. We're going to substitute that. Substitute s equals 0. Once s equals 0, you get negative 12 on this side. Here, if you find s equals 0, this is gone. And then here you get b times, if you find s equals 0, is negative 4. And this terms is also gone. So this says that negative 12 equal b times negative 4. If you divide by negative 4, it says that b equals 3. So we get that right there. And then we're going to substitute more. But you can see that the other numbers you cannot directly get. And also the covering method does not work for these kind of ones, because the square term. And then what we can do is we can still substitute some other values, so that some other terms get 0. For example, there are factors of the s squared minus 4. There are two factors, that means s minus 2, s plus 2. That's going to give you two numbers. That's going to give you plus or minus 2. So we can substitute them now. So we're going to go with we substitute s equal to, if s equal to, what do you get? You get 8. 2 cube means 8, so 8 minus 12 equal, this is 0. The next term is also 0, and here you're going to get s equal 2, so that means 2c plus d times s is 2, that means 4. Now what can we do is, you can see that this is simply negative 4, so you can divide by 4 both sides. Once you divide by 4, you're going to get an equation which is negative 1 equal 2c plus d. So that's the equation you get after you divide by 4. Now again, we can also substitute s equal negative 2. So if you substitute s equal negative 2, you're going to get negative 8, negative 12 equal, again 0 plus 0 plus, here you have negative 2c plus d times negative 4 squared is 4 again. Do the same argument. You can see here now you're going to get negative 20. So this is simply negative 20. So when you divide by 4, you're going to get negative 5 equal negative 2c plus d. So these two are very easy to solve. So the goal is to solve them. So what we can do is we can add them first. So once you add them, you're going to get negative 6 equal 2d. So this says that d equal uh, negative 3, because you add them. Once you add them, 2c, negative 2c get cancelled. You get 2d equal negative 6. So that's been d equal negative 3. And then you subtract. When you subtract the bottom one from the top one, so you're going to get d get cancelled. You're going to get 4c equal 5. From that, you can find c. So when you subtract, you're going to get, I'm going to subtract the top, I'm sorry, the bottom from the top. So then you're going to get 4 equal 4c. So which says that c equal 4, c equal 1. So those are two numbers you're going to get there. Now only thing that you need to find is a. To do that, what we can do, we can just substitute another value. That's one way to do it, or just go with the coefficients. I'm going to go with the largest coefficient. So largest coefficient is x3. So if you go with that, so you're going to say I'm going to go with the coefficient. So you're going to say coefficient of the largest term. That's always a nice trick. So if you do the largest term, what are the largest term you're going to get? S cube is the largest term. And how you can get S cube? You can get S cube here, and also you can get x cubed there. So the coefficient is going to be simply a plus c. On the other side here is 1. So that means you can write equation as 1 equal a plus c. But we know that c is equals to 1, which says that a is 0. Okay, so we find all the numbers that we need, and then now we can write the transform there. So it is easy to find. So now what we can write the answer now. So it is L inverse. So we have S3 minus 12 over S squared minus 4, and then we find the formulas. Now we know a equals 0. So that means this term is gone. So we don't have that term because a is 0. And then we can substitute for b, and b, c, and d. So let's do that and split. So that means we can write this form now. So we can say this is simply equals to 3 times L inverse 1 over squared. That's you get from the first term. And from the second term, I'm going to split between one with s and one without s. So that means one with s you can write as s over s squared minus 4. And one without s, which is d is negative 3, so you can pull that out. And then once you pull that out, you can see that that's a constant one. That means you need the square root of the bottom term. So the bottom term is 4, square root means 2, so you need 2. So what we normally do is we can write this one as a negative 3. We can so it's L inverse. I'm going to leave a space there. So it is s squared minus 4. So now what we need is a square root of 4. That means 2. So I'm going to put a 2 there and put a 2 there. Okay. Now you can see that these all we know formulas for that. So let's write the answer now. So the answer going to be simply, so this is 1 over squared. That means t. So that means this is going to be 3t. And then s over squared minus 4, which is in the table, and that with the s1 means it's not sine, it's the other one, so it is cos. So it's going to be cos 2t, and here without s means the sine one, so it is a negative 3/2 sin 2t. So that's going to be the answer for that. And you can see that. So this is also like not a long problem, it's a simple problem, but we do not use the traditional partial fraction argument here. We stop with s squared minus 4 term because there's a formula. There's a formula for that. So we use that argument. So the next example, we can do L inverse s over, let's say s squared plus 1 s squared plus 4. Same thing, just different type of fractions in the bottom. We know that we learn these kind of things in the Calc 2 on the partial fraction method, so it's the same thing. There are no new techniques here. So we can write the form first. So what's the form? So form going to be, so this is s over s squared plus 1 s squared plus 4 identical to the bottom is s squared plus 4 with degree 2. That means the top has to be degree 1. That means it's as plus b plus here you have s squared plus 4. So this is cs plus d. So there are 4 unknown here. Same thing, multiply by the denominator. So you're going to get s identical to um, we have as plus b times the other one plus cs plus d times s squared plus 1. Next, many people like try to distribute this one, but I don't recommend that, because if you do that, you kind of lose the pattern here. So let's not do that. I'm not going to distribute. I'm going to think about how to get the term. So that's much better, because for example, the substitution method does not work if you try to distribute that, and you're going to lose the pattern. So it's to be better to leave it like that. Okay. So but that's what I say. Okay, so and then what we're gonna do is normally, like if you get a problem like that, we always try to use the substitution method as fast as you can, because then that substitution gonna give you the numbers fast. But in this case, you're gonna see that there are no linear factors, so we are not going to use the substitution technique at the beginning. Normally we use the substitution first and then you use the coefficient, because that's much faster. But here, since we do not have them, we just go with the coefficient. Always, if you do the coefficient, go with the largest possible term. So what's the largest term that you can get? You can see that here is squared and then we have s, so that means s3 is the largest term that you can get. So it's going to create a s cube term. So we're going to start with that. So we're going to go with the coefficient of s cube, because that's the largest one. So there are no and then you can see that when you distribute the coefficient of s cube going to be a, and in the other one the coefficient of s cube going to be c, because when you multiply the first term cs and s squared, you will get cs cube, so the coefficient is simply c. So we write it like that. Done. Go to the next one. You see, you cannot find anything, so the coefficient of s squared, so the next smaller. Now do you get any s squared term? Think about how to get the s squared term. You can see that one way to get a squared term is you multiply these two, and there are no other ways to get a squared term here. So that means it's b plus in the other one you get a squared term when you multiply these two, so it's a d. So that's the one we get, but all four are different, so we can solve any of them. So let's go to the next one. So we're going to go with the coefficient of s, that's the next smaller. So you can see it is 1 on this side. How to get the s term? You can see that one way to get s term is 4 times as, so that means the coefficient is simply 4 times a, and yeah, so when you multiply these two you get a constant term. The same idea, when you multiply these two you get a constant term. So yeah, so this is a cube term, and these are square terms, and what we are writing now is the s term. Those are three different things. Good. So the s term is now is on the other one is you're gonna get c, because cs times 1 means c. Good. So that's what you get, and so we're done with all the coefficient terms. Now we're going to go with the constant. Constant means the coefficient of s to the power 0. So just say constant, or just plug in s equals 0. That's the same thing. You can plug in s equals 0, or look at the constant terms. The same thing. Plug in s equals 0, or go with the constant term. So you can see that. So I'm going to say substitute s equals 0. That's pretty much the constant term. Constant. So if you do that, this is 0 on this side. If you plug s equals 0, if you plug s equals 0, all these terms are going to go away. Wherever you see s term, that's going to go away. So you only get 4b. 4b. That's, you can see that's exactly the constant terms. And then the other constant term, the other one is d. So that's what you get. Now the question is how to solve them fast. So that's a very easy way to solve this, and you can see if you look at these two, this and that, um, so you can see that a plus c is equal to 0. That's what it says. So if a plus c equal to 0, so you can write this one as 3a plus a plus c, or just subtract. Okay, so you can subtract them. So once you subtract, you get the answer actually. So that's another way to say that, do that. So there are a lot of ways to do this. You can subtract those two. Once you subtract, yeah, let's go to the subtraction method, because that's like I cannot recommend. So I'm going to subtract those two. Once you subtract the first one from the bottom one. So if you subtract, then you're going to get 1 equal, you can see c get cancelled, one of the a get cancelled, you get 3a. So this implies that a equal 1/3. And then do the same thing, we're going to subtract these two. So you can see if you subtract those two, you have 0 on this side, and then d get cancelled, you get 3b, and then you have 3b, then b equals 0. Okay, now we can use the same formula again. So if a equal 1/3, this says that c has to be negative 1/3 from the first formula, because a plus c is 0. And the bottom one says that if b equals 0, the d has to be 0 as well, from the d formula. So that's it. So we find all four very quickly. Okay, it's not that difficult. So we can find all four right there. Good. So these are the four answers that we were looking for. Now we're going to plug in that, and we can write the Laplace transform of that quickly. So that means the answer is L inverse. So you can see that it's not a long problem, but you know how to do it fast. So this is not, some people do this one. That's why I say, like, don't distribute. It's going to waste too much time. Okay, good. So now we know the answer. We see that the b and d are 0. So those two terms gonna go away. This is 0 and that is 0. So we have only a and c. So a is 1/3, c is negative 1/3. So that means if you write the answer, so a is 1/3 L inverse. So we have s over s squared plus 1. The other one is negative 1/3. So we have s over s squared plus 4. So you can see that they match with the formulas very well. So this is simply 1/3 cosine. Here omega is 1, so t minus 1/3. Again, this is a cosine because you see the s term. That's a cosine one. Yeah, it's kind of crazy because the sine one doesn't have the s. Cosine one have the s. So that's another way to remember that. So it's the, if you see the s, that's the other one. Okay, good. Now you can see here they have 4 there. So 4 means that's omega is squared. So that means omega equal 2. So that means it's going to be 2t. So that's the partial, that's the Laplace, inverse Laplace transform of that. Good. So we talk about like several different types of inverse Laplace transform and how to find them. So I'm going to give you one, but we can see what's the problem there. So for example, so let's look at this one. So find the inverse transform of let's say 2s cubed plus 1 over s over s squared plus 1. So if you want to do that, and you can see the degrees gonna be degrees gonna be 3 in the top and the 3 in the bottom. Since the degrees are equal, what will happen when you write the partial fraction? So you're gonna get an answer like this. So this is gonna be L inverse, because when you divide, even if you use the long division, so you can do long division here, you're going to see that when you divide, you're going to get 2 plus something. Now the problem is, this is a constant. This is a constant, and if you want to find the inverse, we don't know what's going to happen, because remember we talk about what we call the Laplace limit theorem. According to the Laplace limit theorem, it says that the limit has to go to 0. So what's the Laplace limit theorem says? The limit when s goes to infinity, the fs has to be 0. But this is 2. That's not 0. So that means there is a problem now. It's not equal to 0. So that means it cannot be, the answer cannot be a piecewise continuous exponential order function, because we know that if the original starting function is a piecewise continuous exponential, we know that it has to be 0, the limit has to be 0, but that's not the case. You get 2. So that means we need to talk about some kind of different kind of functions, and we're going to talk about something called a Dirac delta function. So we're going to wait to do this kind of problem. So we can't do this right now, we have to wait. So we're going to get a function called the Dirac delta function. Dirac delta function. So there's a kind of weird function called Dirac delta function, but that has many nice applications. So we're going to wait for that. So we can discuss this kind of problems later. And another problem that we cannot do right now is, for example, like something like this. So let's say find L inverse. Let's say you have 3 over s plus 2 fourth power, something like that. So these ones also we cannot do. I mean, even like, let's go to easy one. So like 2. So you put 2 here. If you just put 2 here, we cannot do this. Even with partial fraction method, because we need a new result for that. So that's so what this term make it different. So this term is different. If it's linear, you can see it. So if it is just 1, we can do it. But if we have something else, then we don't know what to do with that. So we need a new result. So so let's talk about that result. That's the shifting property. So we're going to talk about that now. So so I'm going to give you that as a theorem. So theorem, what we call shifting property. Shifting property. So we talked about this earlier, but this is the kind of time that we can use this. So so let's say if fs is the Laplace transform of ft, then what it says that then the Laplace transform of e to the minus at ft is simply f s plus a. So the opposite sign, that's how we remember. So just the opposite sign. So this is what we call the shifting property, and this is very useful for certain problems. So called the shifting property. So it's an eat function. So if you eat a function, what happens? Just shift by a. So it's e to the minus at ft is simply f s plus a. It's called the shifting property. Very important. This is a very important result. Okay. So let's look at the kind of proof. So what's really going on here? So let's look at the definition. So let's use the definition to write the. So I'm going to say proof for that. So so what's the Laplace transform of e to the minus at ft? So So write the definition 0 to infinity e to the minus st, that's the Laplace transform part, and then e to the minus at ft. Now what we're gonna do, we're gonna combine. So we can write this as 0 to infinity e to the minus s plus a t ft. So you can see nothing much happen here. So what simply happen is you just replace s by s plus a. That's it. So that means the same Laplace transform, you replace s by s plus a. So that's why, so that means says that just f s plus a. Okay, so a is any real number. Any real number. Okay. So that's it. So it's a very simple proof, and that's the idea. So you can see that it's just very easy to prove. But this is what we call the shifting property. It has many nice applications. So let's look at some of them, like 1 or 2 applications of that. Good. So we're going to do the first the Laplace transform, and then we're going to do the inverse of that as well. So let's do some Laplace transforms. So let's try to do this. So let's say example, find. Let's try to do these 3. So what is the Laplace transform of e to the minus 4t, and what's the Laplace transform of e to the 3t times t to the 4th power, and actually and then the Laplace transform of let's say e to the minus 2t cosine 3t. So the first one is actually first one is a formula that we proved earlier, but we can see that this is coming from the shifting property. So that means this is L. So it is e to the minus 3t. So what we're going to do, we're going to exaggerate. We're going to say our function is actually 1 here. So then what we normally do is we're going to only think about the function and write the formula, write the Laplace transform, and then do the shifting. So you can see it is s, it is 1, that 1 means 1 over s. So we write 1 over s and then do the shifting. So we do s, so we can replace s by, so this is negative 4, that means you change the sign, so you can replace by positive 4. S you replace by positive, s plus 4, because it's a negative 4. So change the sign, so you get positive 4, so you're going to replace by that. So that means your answer is simply going to be you replace s by s plus 4, so 1 over s plus 4. So you can see that that's exactly coming from the formula. The formula was e to the minus eat function. Remember, that's the eat function. E to the minus 80 is 1 over s plus 8. That's exactly that. A is in this case a equal 4 according to that formula. Okay, so in this case a is simply 4. Okay, let's do the second one. So what's the second one? The second one says that the Laplace transform of e to the 3t t to the 4, the same argument. So what we do, we only look at the transform of that first. So that means it is t to the 4, and we know what is t to the 4 means. T to the 4 means so 4, there's n, that means factorial of 4 divided by s, 4 plus 1, and then you're going to shift s, you're going to replace by s the opposite sign, so negative 3. So this is easy, so you can see that this is factorial 4 divided by so you're going to get s to the 5, but s to the 5 you're going to replace by that. So let's write it. So it is s to the so it's s to the 5, but you have to replace s by s minus 3. So that means your answer going to be s minus 3 to the 5th power. So that's the answer for that. And then the last one, so what we have is, it is e to the minus 2t cosine 3t. Again, we only look at the function, so that's a cosine function. So that means it is s over s squared plus 3 squared, and then replace s by s plus 2. Uh, so so that means what you're gonna get is you can replace s by s plus 2, so it is s plus 2 over s plus 2 squared plus 9. You can leave it like that, or you can even expand. So this is okay, completely fine with that. Or you can expand the bottom and add them. So that means you're gonna get s plus 2 over, when you expand, you're gonna get x squared plus 4s, and then you also get 4 plus 3, gonna be 13. So that's the answer. So you can write one of those forms, so it doesn't matter which one. But you have to be careful when you try to go backward, when you try to find the inverse, you have to be careful with that. So because you don't see the term, so that means if you want to find the inverse of these kind of ones, you have to use the completing square technique. So we use completing square method. Completing square method. And then you can see an example like that. Now let's do a different example. So let's look at this one. So we're gonna do example. Let's say find L inverse of we can say 2s plus 5 over s minus 3 squared. So for this problem, I'm going to discuss three techniques. One that doesn't work, and then the two works. Okay, so let's start with the first one. So what's the first one? So let's see, because what we normally do when you get a problem like that, one technique is we try to kind of use the linearity and try to split this. So let's see what's going to happen if you try to do that. So use the linearity, so it's L inverse equal to L inverse of 2s plus 5 over s minus 3 squared, which is equals to, what's the first term you're going to get? Well, the linearity is there, so that means this is L inverse. You're gonna get this one as 2s over s minus 3 squared. That's what you get. That's the first term. And then from the second term, you're gonna get L inverse 5 over s minus 3 squared. And then you can see that, so this is fine. So there is a formula for that one. There's a formula because this is you can see the main function 1 over s squared, so we can do that. But what about what about this one? So you can see there is no formula for that one because there's a s term in the top, so that means there is no formula. So that means this way doesn't work for this problem. Okay, so we can do that. It doesn't work. So what's going to work? We know that we normally go for these kind of problems, we can use the partial fraction method. So let's use the partial fraction method. Partial fraction. So if you use the partial fraction, so we can write the form. So what the form is, it is 2s plus 5 over s minus 3 squared. So which is identical to, this is a repeated term, so that means a over s minus 3 plus b over s minus 3 squared. That's what you get. Now what we do is we multiply by the common denominator, so that means this is going to be 2s plus 5, and then this is going to be a, the missing term is s minus 3 plus b, and then we know we're going to use substitution technique, so we're going to say s equal 3. So if you do this is substitute s equal 3, this side is going to be 11, this side is going to be 0 plus b, so this says that b equal 11. And then you can also use a substitution, like another you can substitute something else, like for example you can say just substitute anything else, any number you like. So for example the best one would be like 4. So if you substitute 4, then you can see that you're going to get here you're going to get 13 equal a plus b. That's what you get. And then since you know b, you can find a. That's one way to do it. What's the other way? We're going to get the coefficient method. So you can try anything you like. So I'm going to go with the coefficient technique. this is even much faster. So we're going to go with the coefficient of the highest term. Highest term is s in this case. So the coefficient of highest term s is 2, and you can see on the other side is how you get s term. Only way to get s term is you multiply a with s. So you can see the coefficient is simply a. So that's directly says what is the coefficient. So a equal 2. So done. You find a and b. Now what we're going to do is, since we know a and b, so our formula is simply going to be a equal 2. So it's a 2 over s minus 3 plus b. B was 11. So 11 over s minus 3 squared. Okay, now what we can do, we can do the shifting property, because we have s minus 3. So if you forget about the minus 3 term, it is like 1 over s. 1 over s means a constant, like 1. And then if you look at the other one, you can see, if you forget about the negative 3, it is like 1 over s squared. 1 over s squared means t. So, and then after we write that, we can write the shifting part. When you do the shifting part, you can see here a is simply negative 3 for this one, and also here a is negative 3. So a is negative 3, so we can use the formula, and we can get the answer. So that means now we can write the final answer for that. So we can see L inverse 2s plus 5 over s minus 3 squared, which is from the first term you're going to get, so 2 is a constant, so we're going to pull the 2 out. So let's write it. So it is 2 times L inverse 1 over s minus 3, and then from the other one 11 times L inverse 1 over s minus 3 squared. So now what's going to happen now? So when we do this kind of problems, we forget about we're going to forget about this shifting term. So we're going to forget about that. So we can ignore that and then just think of the s term only. That's how we normally do. And then we're going to shift that. So so that means in this case you can see it is simply, so it is 2 times 1 over s. 1 over s means 1, and then we have the transformation term from s minus 3. So what's the transformation term? It is e to the 3t, plus the next one we have 11, and then 1 over s squared, that means t, and the transformation term is a negative 3, so positive 3t. So you can simplify this a little bit, and you can see that e to the 3t is common, so you can write this one as 2 plus 11t and then e to the 3t. So so that's how we do it, and you can see that the partial fraction method works for this problem. And then let's talk about another one that's much faster, just an algebraic trick for these kind of problems. So let's talk about that. So what we call the algebraic trick. So so we can start with, so what we have is 2s plus 5 over s minus 3 squared. So what we're trying to do is, you're going to try to create a term from the bottom, because it's s minus 3 squared. So we see whether we can create a s minus 3 term on the top. So what we're trying to do is, we can say 2. So we write s minus 3, but if you write s minus 3, what do you get? You get, when you multiply the constant, you get negative 6, but you actually need is 5. So that means you have to add 11 to get 5. So that's what we do. And then s minus 3 squared. Now what we do is, common trick, we can split this into 2. So we have 2s minus 3 over s minus 3 squared, and from the other one s minus 3 squared. And then you can see that one of the term get cancels, so then you simply end up getting 2 over s minus 3 here, plus 11 over s minus 3. So you get squared. So you can see that you get the answer much faster, and then you can see that this is the exact same thing that you get from partial fraction. So so same as partial fraction answer. It should be partial fraction answer. So in mathematics, it doesn't matter what method you use, you get the same answer. But what I'll tell you, so there's a quick algebraic trick that works and you get the answer much quicker. So you can see that there were like three methods. The first one actually didn't work. The linearity didn't work and you cannot do that. And then the second one was the partial fraction method. And you can see that's like kind of a common standard trick. And then the third one is the algebraic trick that much faster and works for these kind of problems. So as the next example, let's do this one. So how about say L inverse of, let's say s plus 1 over s squared plus 4s plus 8, something like that. So you can see that the bottom is not factored. So what we first do is we do the completing square because you write a square term. So let's say note that s squared plus 4s plus 8. How to do the completing square? What we normally do is we get half of the coefficient. That means 2. Half of the coefficient 2, and then we can square that. So we can write this one as s squared. Half of the coefficient, we write 4s, and then we get the half of the coefficient is squared. So that means we write this one as 2 squared, and then we have the rest is 4. So we write it like that. And then you can see that the first term is simply s plus half of the coefficient is squared, that's plus 1. So we do the completing square first. Okay, so the completing square. Completing square. And then we can do the rest of the problem. So what we're trying to do now, so let's look at the problem. So we write like this. So let's say L inverse s plus 1 over s squared plus 4s plus 8. So this is simply equal to s inverse, L inverse. So we have s plus 1 over s plus 2 squared plus 4. So what you want to do is you can see that we have this plus 2 squared term. So this is like either close to sine or cosine. But in the top, you also need to have s plus 2 term. So that means what we're going to do is we're going to write this one as L inverse. So we're going to say s plus 2 and minus 1. So add 1, subtract 1. So we can write this one as minus over s plus 2 squared plus 4. 4 means 2 squared. So now what we can do is we can split them. So if you split them into 2, so this is s plus 2 over s plus 2 squared plus 4, which is 2 squared, minus L inverse. We have s plus 2 squared plus 4. You can see that the a is omega is 2 now, because the form is omega squared is 2. So this says that omega is squared equal 4. That means omega equal 2. So that means what we normally do is we're gonna add and multiply by that. So we're gonna multiply by 2 and divide by 2 outside. So we can do that. Slightly change this. So we're gonna say minus 1/2 so that they match. Okay, it's gonna match. So we have 2 here. Good. Now you can see that this is just a shifted version of sine and cosine. So here a is equals to 2. A is equal to, the first one is the sine version. So this is a sine version. This is a cosine version. This is a cosine version. And that's the sine version. This is sine version. So that means we can write it, but this is shifted version of that. So s plus 2 is there. The 2 is the shifting term. Uh, so let's write it. So there are different 2's. So that means the final answer going to be now. So we can forget about the s plus 2 inside. First think of the right form. It's a cosine, and then omega is 2. That means cosine 2t, and then multiply by the shifting version. So that means so you can see that so in the first one you're gonna get the cosine. So it's e to the negative 2t. That's coming from that, the shifting part, and then we have cosine, and then we have the cosine 2t, because that's the form. So you multiply e to the negative 2t because of the s plus 2 term, and then minus 1/2. So what happened here is the sine is, again, we also have the shifting term because we have s plus 2. That's gonna shift. So that means it is e to the negative 2t sine 2t. So so that's what you get. Okay. So you can see that there are certain problems that you can use this shifting technique too, right? So when you do the shifting technique, what we normally do is we're gonna forget about this part. We're gonna forget about this part. We ignore this part. That's how we did. We ignore that also here. So we're gonna ignore that and try to figure out what is the right form. So you can see that right form in the first one is the cosine, right form in the second one is the sine, and then you do the shifting part. For the shifting, it is plus 2. That means you have to have the you have to have this term. So this term is coming from the shifting part, and also here that's the shifting term. So that we do, you multiply by that, that's gonna shift, because that's the shifting theorem says. So you just need to multiply by e to the minus 80 term to shift the function. So you think of the original one and then shift it. Okay, so that's it. That's what we will discuss in this one. So as the practice problems, you can try these. So you can try these as practice problems. So I'm gonna give you like a few, so you can try them. So these are exercise. So let's start with this one. So let's say find the uh, inverse transform. So you're gonna say for so I'm just gonna write the fs terms here. So let's start with the first one. So let's say we have s squared plus so let's start with something like easy that you can do. So let's start with this one. Let's say for s minus 12 over s squared plus 9, and then b, so let's do 4s plus 7 over s minus 3 squared, and then we're going to do s plus 2 over s minus 1, s plus 3, and then d, we can try s squared minus s plus 4 over s plus 1, s minus 2, s minus 3. Then the e, how about this one? S squared plus s plus 1 over s3 plus s. I'm going to give you the answer for this one. See whether you're going to get ft as 1 plus sine t for this one. You should get 1 plus sine t. And then f, so let's do this one. So we can probably try S squared plus s plus 1. You can see they are all different types. S squared plus 4, s squared plus 9, and then g. So let's do like little tricky one. Yeah, actually let's do the completing square one. So s minus 5, so one is s and one is 5. S squared minus 4s plus 9, and then this one, s over 2 plus 5 over 3, and then we have s squared plus 4s plus 6. I'm going to get the answer for the last one also, so let's see whether you're going to get this answer for that. So it has to be 1/2 e to the negative 2t cos square root 2t plus square root 2 over 3 sine square root 2t. See whether you get that as the answer for the last one. Okay, so you can find the answer for the rest in the description. And then what you have next is the common Laplace transform tables that can be useful when you try to solve problems, either find the transform or find the inverse transform. Thank you.